Welcome to my channel SK Vidyan Physics classes. We shall discuss some important questions on physics for NEET examinations. First question: in an LCR series circuit, the AC voltage across resistance, inductance and capacitance come out as 10 volt, 10 volt and 20 volt respectively. The voltage across entire combination is 30 volt, 10 root 3 volt, 20 volt, 10 root 2 volt. In case of inductance, the inductive current is lagging current, capacitive current is leading current, and the current and voltage in case of your resistor, they are in same phase. So the inductive voltage is leading voltage, capacitive voltage is lagging voltage, because capacitive current is leading current, voltage is lagging one. So the total potential, effective potential across the combination can be obtained by vector means. Now the potential across inductor and across capacitor are out of phase, that is phase difference is pi, and they are represented. Inductive voltage is taken along positive y-axis, capacitive voltage taken along negative y-axis, and VR, that is voltage across the resistor, is taken along x-axis. So effective potential is Vc minus Vl whole square plus Vr square root under. As per the question, Vc is 10 volt, Vl is 10 volt, Vl is 10 volt, and Vc is 20 volt. So 20 minus 10 is 10, 10 square, Vr is 10 square. So the answer is 10 root 2. This is a very important question. Second question: the operating voltage of an X-ray tube is 50,000 volt. The shortest wavelength of X-ray produced is 0.25 10 to the power minus 11 meter, 25 10 to the power minus 11 meter, 2.5 10 to the power minus 11 meter. Fourth choice 5.2 10 to the power minus 11 meter. Now the question is, when an electron is accelerated through a potential difference V, the amount of energy gained by it is equal to EV, and this electron, when strikes or collides a target, X-ray is emitted. So if all energy is converted to X-ray, then H mu, that is the energy of X-ray photon, equal to EV, so that lambda minimum equal to Hc by EV, and putting the values of H, speed of light, and charge of electron, we have 12,345 by 50,000 angstrom. This is equal to 2.5 10 to the power minus 11 meter. Next question: Wien's displacement law can be used to determine, first choice, the mass density of star, charge density of star, radius of star, temperature of the star. Answer is temperature of the star. Now from Wien's law we know lambda m into T is constant. What is it? Now if I is the intensity of radiation taken along y-axis, lambda is the wavelength taken along x-axis, then the curve is obtained like this at a temperature. Now it shows that the intensity of radiation attains a maximum value for a particular wavelength lambda m, say. Now if you increase the temperature, the intensity of radiation is maximum or attains its peak value at another value of lambda, say lambda m 1. Here it is seen that the lambda m, values of lambda m shifts to the left, that is it decreases, so that lambda m into T is constant. More is the temperature, less is lambda m. So from this concept we can find out temperature of star. Next question, by what percentage should the pressure be increased for a given mass of gas so as to decrease its volume by 10% at a constant temperature? Choice is 8.1%, 9.1%, 10.1%, 11.1%. Now, because temperature is constant, we can use Boyle's law, that is PV equal to constant. Now, let final pressure be P dash, final volume be V dash, initial pressure be P, volume be V. Since the volume decreases by 10%, so V dash becomes V, 10% means V by 10 equal to P into V, or P dash 9 times V 10 by 10 equal to PV. So P dash equal to 10 P by 9. P dash equal to 10 by 9 P. So the change in pressure delta P equal to 10 P by 9 minus P, that is equal to P by 9, or change in pressure per unit original pressure P equal to 1 by 9. In terms of percentage, delta P by P into 100 equal to 100 by 9, or 11.1%. So the answer is 11.1%. Next question, greater accuracy in the determination of the position of a particle with an optical microscope can be had if the beam of light used is polarized, has greater intensity, has higher wavelength, has higher frequency. Now, if you take a microscope, say like this, and this is the position of a particle, and radiation is incident on the particle. Now the radiation gets scattered by this particle and enters into the microscope at an angle, say theta. Because of diffraction, the image of this point object will be no more a point, it will extend, and if delta x is the amount of extension, then delta x equal to lambda by sine theta. So less the extension, more precisely the measurement of x. This shows that this is possible with a smaller wavelength of light, that is higher frequency, and we know the resolving power of microscope is inversely proportional to wavelength. So the correct answer is has higher frequency, that is wavelength should be small. Next question, the potential difference V across and the current I flowing through an AC circuit are given by V equal to 5 cos omega t volt, I equal to 2 sin omega t ampere. The power dissipated in the instrument is 0 watt, 2.5 watt, 5 watt, 10 watt. Now we know the formula that power dissipated equal to V, that is V RMS, I RMS cos phi, where cos phi is the power factor. Now phi, the phase angle between voltage and current, here is pi by 2, because this is cos omega t, this is sin omega t. So phase difference is pi by 2, and cos phi equal to 0, or power dissipated is 0. Next question, the momentum of a photon is 6.6 10 to the power minus 29 kg meter per second. The frequency of radiation in hertz is first choice 3 10 to the power 13, 3 10 to the power 8, 3 10 to the power 15, 3 10 to the power 6. This is a very important question. We know the energy for a relativistic particle is equal to p square c square m0 square c4 root under, and this is applicable also for the photon. Photon has rest mass equal to 0, so energy of photon equal to Pc. Further we know the energy of photon equal to S mu, that is Pc equal to S mu or mu equal to Pc by lambda. You have to find out the frequency that is Pc by lambda. Value of P is taken 6.6 10 to the power minus 29 SI unit. Speed of light is 3 into 10 to the power 8 meter per second. Value of Planck's constant is put here. So the answer is 3 into 10 to the power 13 hertz. Next question is, a pair of coils of turns N1 and N2 are kept close together. If a current passing through the first is reduced at the rate R, an EMF 3 millivolt is developed across the other coil. If the second coil carries current which is then reduced at the rate 2R, the EMF produced across the first coil will be 6N1 by N2 millivolt, 6N2 by N1 millivolt, 6 millivolt, 3 by 2 millivolt. We know this is a very simple question. Now, if we have two coils placed close to each other, coil 1, coil 2, EMF induced in coil 1 due to the change of current in coil 2, E1 equal to minus M1 dI2 by dt. That is, EMF induced for unit rate of change of current is equal to constant for the two circuits, that is M1, which is called mutual inductance. Now, in our question, if R is the rate of reduction of current, then EMF induced is 3. So 3 by R equal to, in second part, the rate of change of current is made twice, so that if X is the EMF induced, so X equal to 6. Simply the answer is 6 millivolt. Now, next question. For a collimated beam of electromagnetic radiation, the pressure is P equal to E by C. If the beam falls normally on a surface which reflects a fraction X, transmits a fraction Y, and absorbs the rest, the pressure experienced by the surface is 1 plus X minus Y into P, 1 minus X plus Y into P, half into 1 plus X P, last choice half 1 plus Y into P. Now the question is, supposing we take a surface and the beam is incident perpendicularly and the pressure is P. Now, some portion of the energy is reflected, X part is reflected. That means when a particle gets reflected, it transfers momentum or hence pressure to the surface, and the pressure exerted along the direction of the incident beam. So P plus 1 plus XP. Next part, the rest of the energy partly absorbed and partly transmitted, and this portion of the energy is not responsible for exerting any pressure. So you can deduct this amount of pressure so that the value of the pressure exerted is 1 plus x minus y p. Supposing if you consider that the energy is incident without any reflection, or without reflection means x is equal to 0 and y equal to 0. If y equal to 0, x is equal to 0, then pressure exerted equal to P. Supposing all the energy incident gets reflected, then y equal to 0, x equal to 1. So in that case, the pressure exerted is 2P. This is how we can find out the solution, that the pressure exerted is P into 1 plus x minus y. Next question is, a uniform ring of radius r, and mass per unit length rho is spun about its axis with an angular velocity omega. The increase in tension due to stretching of the ring is proportional to rho r square omega square, rho r omega square, rho r square omega, rho to the power half omega square r square. How to solve this problem? Now let us consider the ring here and take an elemental length, say angular length is theta, so r theta is the length of the elemental part of the ring. Now it revolves at a velocity omega, and it is given that mass per unit length is rho. Now the mass of the elemental ring is rho into r theta. So when it revolves at an angular speed omega, the centripetal force is m omega square r. This is the centripetal force. Now what happens? If there is a tension, then tension is shown here like this. Then this angle is theta by 2. So tension here has two components, and this is perpendicular to this one, this is perpendicular to this line. So this angle is theta by 2, and this component is 2t cos theta by 2, and this component along this direction is t sin theta by 2. Now the components, that is horizontal components, get cancelled. So the net force acting on the elemental part due to the tension is 2t sin theta by 2 should be equal to rho r theta omega square r. Now theta is small, so that this is 2 theta by 2 equal to rho r square omega square theta, and tension equal to rho omega square r square. So the correct answer is rho omega square r square. Next question is, if T is the time taken for light emission by an atom and Tf is the time taken to release energy by nuclear fission, the ratio Te by Tf is 100, 1 by 100, 10. Answer is C, that is 1 by 100. How? Te is 10 to the power minus 8 second usually, and Tf 10 to the power minus 6 second. So Te by Tf is 10 to the power minus 2. Correct answer is C. Next question is, boron rods are used in nuclear reactors because boron can absorb neutrons, strength is given to the plant, boron speeds up neutrons. Next choice, reactors look good, but answer is boron absorb neutrons. So Thank you. I shall come in next video with more questions. Thank you.